Okay. Yeah, Ajit, we'll get started. So I'll be recording this mock interview. Okay, you're comfortable, right?
Yes, Manoj.
Yeah,
I'm
sure.
comfortable
Yeah,
with that. Yeah.
yeah. Thanks, Ajit. So we'll get started then. So can you walk me through your professional journey?
Yeah, sure, Manoj. So I'm Arijit. I started my professional journey 10 years back. I joined this company where I'm currently working. From past 10 years, I'm working in the same company, and I joined as a Linux support engineer. And since then, I have changed into different roles. I have moved into system admin, and then the system admin role got converted to cloud engineer as there was transition happening from the monolithic systems to cloud. And then it was not truly cloud. As cloud engineer, I was working still as system admin, but managing Cloudera systems. Our own the client that we were supporting had its own data farm, so we were supporting the physical servers and the Cloudera clusters. Post that, from last 2.5 years, I am working as a DevOps engineer for
Okay,
an analytics workload.
okay. Yeah, that's awesome, Ajit. So since you are a Linux guy and sysadmin guy, so
Yeah.
like, can you tell me about your like background, like, or like what are all the hard phases you come across when you are transitioning into DevOps?
Yeah. So I can say that in last 2 years, the biggest challenge I had faced is the operational part. So as a sysadmin, our job would end as soon as we configure the environment files for the operational or the DevOps engineers, right?
Yes.
So, for instance, let's say someone comes and tells, "Hey, I need a storage. Or I need a bunch of servers to host so and so application." My job would be to ask them what ports they want to be exposed, how the connection they want, and then configure those. And then that's it. My job would end there.
Okay.
So this is the first time I got to work on the application side of things. So definitely one of the key benefits I had was having known the background process. Sometimes what happens is when we have dedicated teams, right? One team is they are configuring the backend network and the cluster, and then there is another team that is hosting the application in it and managing the application, which is DevOps engineers. Now,
Okay.
having known the background information, it was very easy for me to, understand, oh, why is SSH not working, or how this application actually hosts, how the network in the network it communicates,
Okay.
where certificates come into picture. So these things were obviously an added benefit.
Mm-hmm.
uh, but the biggest challenge, if I have to say, was
Mm-hmm.
transitioning to learn the applications itself. Like I had to start from scratch to understand what the application does and what are its capabilities.
Okay. That's awesome, Ajit.
Yeah.
So yeah, what are your like day-to-day responsibilities as a DevOps and since you are into a leadership role, as I see your resume, and what are your like day-to-day activities or roles and responsibilities?
Right. Yeah. So from last 2 years, I am handling analytical workload team, mostly DevOps. So day-to-day responsibilities include coming onto shift and ensuring that all our engineers who are using our platform, they don't have any blockers. They are able to use the environment to query data, and they are able to store the data, analyze data in our data stores. So
Mm-hmm.
ensuring platform stability and availability, that is one of the first things that we do.
Mm-hmm.
We achieve that with the help of observability tools like Grafana, which is hitting the different data stores, be it
Mm-hmm.
Iceberg tables in S3 or Postgres table in databases. And also, like through Prometheus, we fetch all the Kubernetes
Okay.
logs, whether the pod is up or so and so forth. And then
Oh.
once this part is done, the
Mm-hmm.
next aspect of the day-to-day activities would include
Mm-hmm.
ensuring, so we also have access to the code
Okay.
that are deployed in the Kubernetes app environment. So
Mm-hmm.
we ensure that the build and the CI/CD pipelines, they are all working fine. So we check that.
Okay.
And lastly, since these are analytical based workloads, so we look into the whether if something is broken, there are let's say somebody's analytical workload got broken somewhere in
Mm-hmm.
the pipeline, we
Okay.
troubleshoot it and then find what happened, what went wrong.
Okay. Okay. Understood. So where is your
Yeah.
application hosted? Is it on
So our
EKS?
application,
Uh,
yes, right, right. Our applications are hosted on AWS.
EKS. Okay. Is it a internal or internet facing?
Um, our EKS is internal. I don't think it is internet facing.
Okay. Okay.
Yeah.
So yeah. So since you okay, and are you handling
But
any pipelines?
I
Yeah. Go ahead. Go ahead, Achal.
yeah, yeah. I just wanted to say that when I say internet facing, I mean the public internet facing. But then
Correct.
since we are using an external technology, right, like
Mm-hmm.
EKS,
Mm-hmm.
our data centers to EKS,
Mm.
the transmission of the network, I mean the data or
Mm.
whatever config, that is happening over the internet,
Okay.
but it's not public facing, is what I mean.
Okay. 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 Got it. It's kind of a internal, your organization internal use, right? That particular application.
Yes,
Okay.
that's right. Yes.
Yeah. So have you configured any pipelines for that?
A few. Having progressed into the lead role, I
Mm.
got very rare chance to
Okay.
work on it on a day-to-day end. But then, yes, I have configured a few pipelines.
Okay. In your application, how many microservices you guys are maintaining?
We have roughly about 40 microservices.
Okay.
The core application has around like 18 microservices which are running, and then
Oh,
overall it would come to about 40.
okay. Okay. So yeah, that is awesome. So, so tell me one thing, like, how do you balance an architecture designs and operational work in your like as a lead?
Okay, so uh, first things I want to clarify from the get-go is
Okay.
uh, I transitioned into this team when the architecture was already designed and developed.
Okay.
But since I was coming from a cloud administration kind of field,
Mm-hmm.
we did have, like, for instance, I can talk about Trino, the query engine, right? So we
Okay.
had a standalone Trino query engine running on a
Mm-hmm.
bunch of physical servers which we
Mm-hmm.
had clustered
Okay.
manually.
Okay.
And we were transitioning from doing this,
Mm-hmm.
like using this self-managed
Mm.
Reno cluster to
Mm.
auto-managed managed service type
Okay.
of Reno cluster.
Okay.
So yeah. To answer your question, like how we design the architecture or things like
Mm-hmm.
that,
Mm-hmm.
this was a one time operation. But then
Mm. Yeah.
the best way to go around was
Mm.
understanding, like we would have meetings with all our stakeholders who are going to use our application, at least
Okay.
on a high level. And
Okay.
then we would gather the requirements that, okay,
Mm.
our engineers are spread across the globe.
Mm.
People in, let's say, US region, people in China region, people in India region, and so on and so forth. And then they need to be able to connect to the same data stores at subpar millisecond
Mm.
response times. So
Mm.
then this is where, like, we start from scratch, and we start building things like, okay, where is our application hosted? Let's
Mm-hmm.
say the
Mm-hmm.
application is hosted in US region, right?
Okay. Okay.
Okay, if it is in EKS in US region, then how do we ensure China has a per millisecond delay? So that's where the geo
Okay.
load balancers come into the picture. So we would configure GSLDs, and then
Mm-hmm.
expose the traffic, right, and then do benchmarking.
Oh.
So uh, sort of like that, yeah. This is how the architecture design planning would go. And
Mm.
then
Okay.
I believe you also asked a second part question to that. How do you
Yes.
handle,
Mm.
yeah, like how do you handle with architecture design and your day-to-day operations?
Yes.
So yeah, so once the architecture has been designed,
Mm-hmm.
then comes enforcing that architecture and enhancing that architecture. So we have to keep checking for vulnerabilities, keep checking for new technologies or new features that are coming. Let's say
Mm-hmm.
today we are using Spark 3.4.0, tomorrow we have 3.4.3.
Okay.
Sometimes, as part of these upgrades, they eliminate certain,
Mm.
configuration variables or
Okay.
things like that, or they add new features. So
Okay.
we would first create a dummy pipeline, test it
Uh-huh.
out, or we have our UAT environment where we test these things, and then once users confirm things are looking good, nothing
Mm.
is broken, then we push these changes. So this is how the operational end takes place.
Okay, okay. That's great, Arjit. So what are your tech stack since you're mentioning a lot about Spark, Trino, and other tools, right? So can you like brief me about your tech stack, like what and all you know?
Yeah, so tech stack wise, we are using a lot of technologies, but since I mentioned I'm handling the DevOps role for an analytical workload,
Mm-hmm.
it's primarily focused on data analytic based applications. So
Okay.
we have our data in S3 as iceberg table format,
Mm-hmm.
and then underneath, we are using a wrapper on top of Iceberg because our analytical workload, given how the data of the client is, we have a small data set based off workload, like a few 100K rows or 10K rows. Versus we also have a heavy analytical workload where we can have like millions of rows being analyzed on a hourly basis. So to handle both these situations, we have two querying engines. We have Trino and Spark.
Okay.
And given the limitations of Trino, we had to go with Hive Metastore as our catalog. So we can't use a different catalog here. And
Mm.
then uh, we are using uh, Airflow for
Mm-hmm.
managing our data pipelines.
Okay.
So we configure the DAGs, the directed acyclic graphs, and then
Okay.
it's a one-time job.
Mm.
We like mostly the developer team
Mm-hmm.
has written the code, and
Okay.
then we only work on the enhancements and minor bug fixes
Fine.
and so on and so forth.
Okay.
Right. Yeah.
Yeah. How about Kubernetes,
Uh,
Docker, and
yes. So our applications are all hosted in EKS,
mhm.
AWS EKS, which is Kubernetes basically. So and we use Docker for building our container images.
Okay, okay. So, and you were storing your images in where? ECR or Docker Hub?
Sorry, what was the other thing you mentioned?
Like
ECR.
ECR, like in Amazon we have a ECR, right? Container registry, like where you store your images. So,
Right.
which one you are
So
using?
we are actually hosting our own because our
Ah,
client has their
okay.
own private cloud. So we have similar to Docker's standard repository. We are not using ECR. We are using the Docker's
Okay.
fork of the yeah.
Understood. Yeah. So suppose I want to build one high scalable microservice application. Let's say I have like 4 5 microservices. So how would you
Mhm.
design with your like skills? On your experience, can you tell me like I'm expecting like since you were a lead and you know a lot of things about different tech stacks and all. I want you to like build a like let's say we need to decide on application like build an microservice based application like it is like per minute it is handling like 1 million requests. So how do you handle this kind of architecture or how do you like design it basically?
Right. So that's a brilliant question, Manoj. this is something most companies
Mm-hmm.
start off with like millions of queries, and then we are expecting subpar milliseconds of response times.
Mm-hmm.
Right. So I think the first thing that I would do for starting off with this project is gather more requirements, because I have very little information to start with.
Mm-hmm.
So what I would try to understand is what kind of application is this? What kind of data payloads are transiting through the API calls,
Okay.
and then based on that, decide whether we need to introduce a caching methodology in between. Let's say Redis, right?
Okay.
So we have to then architect a Redis cluster. It could be running in AWS, or it could be a self-managed, self-hosted Redis
Okay.
instance. So introduce Redis in between, cache the data, and
Mm-hmm.
only send the requests to the compute for whatever millions of rows query
Okay.
to the backend database. Only if it's not available in cache, right?
Mm.
And then uh, depending on how things are, we have to make sure that we are using CDNs, we are
Mm.
configuring GSLB with our customers, the end users who are going to consume the data are
Mm-hmm.
spread across the globe. Uh, as for the design of the microservice itself, right? We
Okay.
Kubernetes has different kinds of
Okay.
units, right? Like we have deployments which can be running as a standalone or as a replica set. Then we have daemon sets and stateful sets. So depending
Got it.
on whether we are hosting a database or a
Mm-hmm.
message queue like Kafka or RabbitMQ or something of
Mm.
that sort, we have to
Okay.
figure out whether, I mean, in case it's a database or a stateful set, right?
Mm-hmm. Mm-hmm.
Sorry, my bad, a message queue.
Mm-hmm.
So they have to be as a stateful set, because
Okay.
they are not even they are a stateful way of running the application. The order matters in which the nodes are coming up, uh,
Okay.
and we need persistent data. So those things, like, consider all
Mm.
of this.
Okay.
This is on a high level, but then
Mm.
if you could, like, if we were to go deep down, we
Mm.
would, as I said, we would have to
Mm.
understand what the application is designed to do,
Mm-hmm.
and only based on that I can suggest further what is the best
Okay.
way to design the architecture.
Okay. Okay. That's great, Arjun. So just a follow-up question for this. So let's say there are a lot of transactions happening to our database. So how do you handle your database scaling here?
How do we handle database scaling? So there are first, before we even enter the
Mm-hmm.
matter of scaling,
Mm-hmm.
I would first, from personal experience, the
Mm-hmm.
first thing that I look for is whether the query is optimized. So
Oh.
in case of a SQL query, we would check whether the database is indexed,
Mm-hmm.
and if the indexed columns are being referred in the where clause of the select queries,
Okay.
whether users are doing that.
Mm-hmm.
If it is a NoSQL based database, we have to check what kind of clustering it has. If it is a distributed cluster, check for sharding, and
Oh.
check whether what values they are partitioned by.
Mm-hmm.
Um, right? And then make sure that the partition by columns are being referred in the where clause. This
Okay.
is where I will start from, and then further
Mm-hmm.
to enhance this, we will check uh, whether it's a one-time write and then many read. In
Mm.
which case, to avoid writes from getting slowed down, we
Mm-hmm.
can segregate. Like, we can put two load balancers, one for the reads and one for the write, and then handle the traffic, route the traffic to the backend database in different ways.
Okay, okay, got it. So, how do you hit your traffic to your pod? Like, let's say you have created application, right? Let's say www.arjit.com. Let's say as soon as I hit enter there, okay,
Mhm.
backend, can you explain me the workflow, like where and all it go and how it will reach your pod?
Right. So, uh,
Mm-hmm.
like if I'm hitting a URL, you want
Yes,
me to explain how it goes to the backend pod and fetches
backend part.
everything, right?
Yes, yes, right.
Okay. So this is where we are entering into the control plane. So
Mm-hmm.
uh, basically, let's say I have created a microservice and for www.reg.com, let's say my
Mm-hmm.
microservice is called front end app, right?
Okay.
So uh, basically, when I write my deployment for front end app,
Mm-hmm.
uh, Kubernetes by default would analyze the code and it will create an endpoint. Uh,
Okay.
in Earlier it used to be an endpoint object, but these days I think the newer one is called endpoint slice.
Mm.
So for this application, the endpoint is created, and the reason why endpoint is created is it's for Kubernetes cluster to broadcast to all the other services that hey, there is a new service which is exposed on so and so IP address and so on so port number, and this is how you access it, right?
Okay. Okay.
So now when I let's say hit rg.com and then the request would check for what the IP address is, and it will then if it is in the same network, it will go to the Cube
Okay.
instance. And here Cube would have all these information stored in etcd.
Mm-hmm.
It will expose back. Oh, okay, the service that is looking for based on the endpoint information is so and so.
Okay.
Uh, okay,
Okay.
and yeah,
Okay.
so
Just to
this is one of the
one,
ways.
yeah,
Right.
one follow-up question here. So as soon
Mhm.
as it that domain, right? So
Mhm.
suppose it has to do a load balancing. As I said, it is a 10 million or 1 million requests per minute. Now, if
Right.
you want to handle that request, so like what mechanism you're using behind the domain?
Uh,
Are you using any load balancer kind there?
Okay, yeah. We are definitely using load balancer. We are using for applications. We are exposing. I mean, we are using application load balancers concept
Okay.
for
Okay.
AWS
Okay.
in my current org.
Mm-hmm.
And then we have NLBs or ELBs for
Mm-hmm.
within the cluster services that are exposed.
Okay. Okay.
Basically anything that is
Mm-hmm.
customer facing, like how you said, a customer enters www.lg.com and then that goes via the application load balancer
Okay.
and anything, let's say there is some API that needs to be used
Mm.
between two services, it uses ELB.
Okay. Okay. So let's take a scenario where so you hit
Mhm.
your domain. So domain is transferring your request to load balancer, and now you have four microservices with you. So will you create, or let's say in all the four microservices, when you are like creating a deployment, normally we'll create a deployment and we'll create a service file, right? So in service file, usually if you go with a load balancer, it will create a load balancer IP. In normally NLB, it will create in the UI, right? In the so how do you handle the situation? Let's say how do you connect between these parts? Let's say if let's say let's take one Flipkart application. Let's say slash app or slash cart. Let's say I want to click on cart, it will go to cart microservice. If I'm going with orders, I'll click on orders, it will go to orders. Now how do you handle this kind of thing? Will you go for multiple load balancers here or any other mechanism from the Kubernetes you're using?
Okay, so uh, I'm just trying to understand the question. So
Okay.
basically, my service has a
Mm-hmm.
bunch of APIs,
Yes.
and you're asking if each API requires a different load balancer.
Yes, API in the sense like let's say for microservices. Yeah, the same way. Now, let's say in the service file, right? Usually you will write a service file. So in the service file, you'll create this thing or a service type as load balancer. Now,
Mhm.
so you have front-end load balancer, you have cart, you have orders, you have so many other microservices with you. Now, what you will implement here, like we can't go with, like if I have 10 microservices, I can't always go with 10 load balancers there, right? Instead of that,
That's
uh,
correct.
yeah,
Yeah.
we can go
Yeah.
for
Okay. I think
Ingress. Mm,
I'm getting the concept you are trying to look for. So,
yes. Mm-hmm.
basically, uh, we are trying to do path-based routing, which
Okay.
is basically an HTTP-based routing, right? So
Mm-hmm.
for this, we have a Kubernetes
Mm-hmm.
object called Ingress.
Mm-hmm.
So we basically have to create an Ingress controller, which
Mm-hmm.
would be so first of all, Ingress is a object which is responsible for incoming traffic from some external system to our Kubernetes cluster,
Okay.
right? So
Okay.
we create ingress controllers using, let's say, Nginx or something of that sort, which
Mm-hmm.
basically is a reverse proxy.
Mm-hmm.
And then in the ingress configuration, we can mention in the specification that my app, I mean my ingress app,
Mm-hmm.
would have if the path is, let's say, slash,
Mm-hmm.
then backend will be one service, my microservice. If
Mm-hmm.
the backend path is slash API
Mm-hmm.
or slash cart in your case, then
Mm-hmm.
let's say my backend will be one service with some port number. Let's say if the port number changes for that service, right? And
Okay.
then what? Oh, yeah. So same way we can just
Understood.
keep going. We can keep, yeah.
Yeah,
Okay.
understood, Arjit. So that is what I was looking. And what, like,
Okay.
which Ingress controller you are using in your organization?
We are using Nginx. We have used HA proxy both.
Mm-hmm.
We have used both.
Okay.
I'm not exactly remembering which one we are actively using or which one is more
Oh,
used, but we
okay.
use both equally likely, I feel. Yeah.
Okay. Because now Nginx controller, it's
Hmm.
deprecated, like it's expired, right? So that is why I'm asking.
I
Oh,
see. Okay. Yeah.
yeah. Okay, that's fine. So, and also when you are like mentioning about the architectural design, you mentioned about persistent volumes and other things. So, what is like storage class? What type of storage class you are using? Is it a AWS provisioned or how it is?
Yeah, the AWS provisioned storage class. GP2 we were using, we have gone to
Okay. Okay. Now tell me one thing, where you will use EBS and where you will use EFS. By the way, you know the difference between EBS and EFS, right?
On a high level, yes. When you ask me what is EBS versus EFS, EBS is block stored and EFS is normal file systems, the ones which we had in olden days. We would use NFS, right, which is
Mm-hmm.
network file system. So
Okay.
uh, EFS can be considered as a managed NFS.
Okay.
Um, EBS is slightly,
Mm-hmm.
different than normal block storage. It's not a block storage as such.
Mm-hmm.
From what I understand, the way AWS implements EBS is it
Mm-hmm.
uses physical hard disks on EC2 instances
Mm-hmm.
mounted on connected to a EC2 instance,
Mm-hmm.
and then it builds a block storage on top of that EC2 instance. So it gives the illusion that it's a block store.
Okay. Okay.
Okay.
Okay.
So, and the way it works, I think, is EBS attaches to a single EC2 instance within a single AZ.
Mm. Okay.
Yeah. But EFS is not like that. EFS can be mounted to multiple EC2 instances
Mm.
and across different AZs. So this
Okay.
is like the major difference while which we use to decide whether to use EBS or EFS for our application,
Mm.
depending on whether
Okay.
it will require multiple EC2 instance connectivity and across different AZ.
Okay. Okay. Just to confirm, can EBS be attached to a multiple nodes?
Um, can it be attached? Yes.
Mm-hmm.
Will it work? No, it won't work. So
Okay.
EBS attaches to one EC2 instance in one single AZ. So
Mm. Okay.
while from theoretical point of view, it will be possible to attach,
Mm-hmm.
but there is no practical use of it.
Okay. Okay. So in your application, when you're climbing a PVC, you are going with EBS or EFS? Mm.
That it depends on the so for our instance, like
Mm-hmm.
an example that I can give for our analytical workload,
Mm-hmm.
we have things like transactional
Mm-hmm.
applications which basically handle querying or create the query and then query the data. And
Okay.
then we also have
Mm-hmm.
what should I say, like MySQL or
Uh-huh. Okay.
PostgreSQL kind
Okay.
of pods. Okay,
Mm-hmm.
so these for these we use EBS.
ABS. Okay.
They are available across, yeah, because these are more static and then they are running on only one EC2 instance, one availability zone. Okay,
Okay.
but then we have things like the
Mm-hmm.
front end app, or we have, let's say, things that need to
Mm-hmm.
share certificates, or things
Okay.
where we have to share secrets. So we have a vault manager, and then let's say we want to download all the data to one and then share it across throughout the application. So there we would use EFS.
Okay. Got it. Got it,
Yeah.
Arjun. Yeah, so and also you worked on observability side and all, right? So have you configured any like let's say I'll ask one simple question. So
Hmm.
suppose you since you have main you are in the architecture, right? So you have like a lot of pods with you and microservices with you, a lot of transaction is happening. So where do you store your container logs or application logs? So
Um,
mhm,
okay, so okay, we have live logs running and being generated by the
container.
process that is running in the container. Yeah.
Correct. Yes.
So the
Mm,
yeah. So now this log,
mm,
we have two concepts here.
mm,
Uh, Concept number one is we have last 30 days, up to last 30 days worth of historical data available in the
mhm,
pod itself. As
mhm.
long as the pod is not dead, we are not
Okay.
persisting it across restarts,
Okay.
container restarts, or so on and so forth.
Mhm.
Uh, Apart from the fact that the node level Kubernetes maintains some transactional logs for the whenever there is a crash happening, it
Uh,
maintains that.
Okay.
But
Okay.
then the actual application logs are being forwarded via sidecars.
Mhm.
So we have two different tools we are using for forwarding logs.
Okay.
First we have Splunk sidecar,
Mhm.
which is basically client-based routing. So we have a Splunk forwarder which runs as a sidecar
Okay.
in the same application
Mhm.
deployment.
Okay.
So basically in one pod, we have the main application is called, let's say, main app. So with
Mhm.
that main app container, we also have the sidecar container like Splunk. And then
Okay.
we have a second sidecar, which is running as an init container.
Mhm.
This actually lashes onto the main process.
Mhm.
So this is where we are using OpenTelemetry.
Mhm.
So we use the OpenTelemetry jar file, which basically attaches with the main. If the code is of Python implementation, then it attaches in a certain way.
Okay.
If it is a Java application, then in a certain. And then
Okay.
both
So
of these are. Yeah, sorry, go ahead.
okay. Okay. Sorry. Go ahead. Go ahead, Arjun. Complete it. I'll. So okay. Fine. Let it be. I got it. What you're
Hmm.
saying. So how many
Yeah.
containers are you are using in a single pod right now?
So we have three init containers.
Okay.
We have uh, depending on the application, we have two to three
Okay.
main containers.
Okay.
So the difference, yeah, the difference is init
And
containers are, yeah, like they come up, they set up the environment and they terminate, and
mm,
then main container and sidecar keeps running.
okay. 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 Just one last question from my end. So
Mhm.
is let's say, see, since we are maintaining I mean talking about containers, right? So
Mhm.
let's say you have a init container, you have an actual container, and this Splunk, I mean whatever the sidecar container you mentioned. So I have three containers in my pod. Now, in order to start my container, I need init container to complete. Correct, right? You're getting right till now?
Correct.
Yeah.
Yes. Yeah.
Now, how in a deployment file, okay, in a deployment file, let's say if init container completes, where that init container will write all its secrets in the pod. Will it directly
Okay. Yeah.
forwarding? Yeah, go ahead, Archit. Yeah.
Yeah, I got your point. So basically, we will have a persistent volume mounted
Mhm.
into the pod's deployment
Okay,
config, right? And
but
then
okay, just
yes,
one question, Arjit here. Since you mentioned about persistent volume, right? Every
yeah.
time if you go with a persistent volume here, like
Mhm.
you mean EBS volumes or a empty volume directory, like a ephemeral directories.
Um, uh, so we can use both. If it is secrets we are talking about, then
Yes. Mm-hmm.
if a bot dies or if there is
Mm-hmm.
a container restart happening, right? So anyways, we will lose the data and the init containers will start again. So we
Okay.
can use an ephemeral volume so that
Mm.
we don't have to persist the data across the restarts.
Okay. Okay.
Yeah.
Okay, Archit. Got it then. Yeah. So
Okay.
yeah,
Yeah.
then yeah, you have any questions for me?
No, this was a great thing to do. As I mentioned, like I have been working in the same company organization for 10 years across different roles. This would be probably my first interview in a long time.
Okay.
So it was a great opportunity. Thanks very much.
That's awesome. Awesome. Yeah. Thanks, Arjit. Thanks for your time. Yeah.
Yeah, thank you.
Thank you.